Welcome back to Borax Solutions. Today, we're continuing our deep dive into the world of technology by exploring machine learning, or ML. If you've heard the term but aren't quite sure what it entails, or if you want to understand how this powerful technology is shaping the future, stick around. We'll cover what ML is, how it works, the different types of models, and why it's such an essential skill in today's world. So what exactly is machine learning? At its core, ML is a branch of artificial intelligence that enables computers to learn from data without being explicitly programmed. Instead of writing code to tell a machine exactly what to do, we train it with data, and the machine learns patterns and makes decisions based on that data. This is what powers everything from recommendation systems on Netflix to fraud detection in banking. Why should you learn about machine learning? Well, ML is one of the most versatile and impactful tools in tech today. By understanding ML, you can unlock new career opportunities, enhance your problem-solving skills, and contribute to innovations in various industries. Whether you're a data scientist, developer, or business analyst, ML can give you the edge to solve complex problems and create value in ways that were previously unimaginable. Let's break down the key elements involved in machine learning. 1. Data. The foundation of ML is data, lots of it. 1. This data can be structured, like tables of numbers, or unstructured, like text or images. 2. Algorithms. These are the mathematical models that analyze the data. 2. Algorithms can range from simple linear regression to complex neural networks. 3. Training. This is the process where the algorithm learns from the data. 3. The more data it processes, the better it gets at making predictions or decisions. 4. Model. After training, the algorithm becomes a model that can be used to predict outcomes based on new data. 5. Evaluation. Finally, the model is tested and refined to ensure it works accurately and effectively. Machine learning isn't one size fits all. There are different types, each suited to different kinds of problems. 1. Supervised learning. Here, the model is trained on labeled data. 1. For example, in email filtering, the model learns to classify emails as spam or not spam based on examples provided during training. 2. Unsupervised learning. This involves training the model on data without explicit labels, allowing it to identify patterns or clusters on its own. 2. An example is customer segmentation in marketing. 3. Reinforcement learning. This type focuses on training models through trial and error, rewarding them for correct actions. 3. It's often used in robotics and game AI. Let's talk about large language models, or LLMs, which are a subset of ML, particularly in the domain of natural language processing, NLP. LLMs like GPT-4, which powers this conversation, are trained on massive datasets of text and are capable of generating human-like text based on prompts. There are different types of LLMs. 1. GPT, Generative Pre-trained Transformer, a model that can generate coherent and contextually relevant text. 2. BERT, Bidirectional Encoder Representations from Transformers, a model focused on understanding the context of words in a sentence for tasks like text classification. 3. T5, Text-to-Text Transfer Transformer, a model that frames every NLP task as a text-to-text problem, making it highly versatile. To deepen your understanding, let's touch on a few more key concepts in ML. 1. Overfitting and underfitting. Overfitting happens when a model learns the training data too well, including noise and details that don't generalize to new data. 1. Underfitting happens when the model is too simple to capture the underlying patterns. 2. Feature engineering. This is the process of selecting, modifying, and creating new features, variables, from raw data to improve the model's performance. 3. Hyperparameter tuning. This involves tweaking the model's settings to improve its performance. 3. It's like adjusting the knobs on a radio to get the best signal. 4. Cross-validation. A technique used to assess how well a model generalizes to an independent dataset, helping to prevent overfitting. Just like in AI, there are several industry leaders in machine learning. 1. Google. Through its TensorFlow platform and numerous ML research projects, Google is at the forefront of ML innovation. 2. Microsoft. With Azure ML, Microsoft provides tools and services to build, train, and deploy ML models at scale. 3. Amazon. AWS offers a wide range of ML services, including SageMaker, which makes it easier to build, train, and deploy models. 4. IBM. IBM Watson is another major player known for its AI-powered analytics and ML solutions. 5. Meta. Facebook. Meta invests heavily in ML for social media, advertising, and their vision of the metaverse. So, what's next for machine learning? We can expect ML to become even more integrated into our daily lives, powering everything from smarter virtual assistants to personalized healthcare. As models become more advanced and data availability grows, ML will play a key role in solving some of the world's most challenging problems. However, this also raises ethical considerations around data privacy, algorithmic bias, and the impact on jobs, which the tech community must address. Machine learning is transforming industries and lives at an unprecedented pace. By learning and mastering ML, you're not just preparing for the future, you're actively shaping it. In our next video, we'll dive into deep learning, exploring how neural networks are taking machine learning to the next level. Thank you for tuning in! Don't forget to like, subscribe, and hit that notification bell so you never miss an update. And if there's a specific topic you'd like us to cover, leave a comment below. Until next time, keep learning and innovating.